it's always one of those things that you know, you're so used to doing it yourself that it's never an issue for you to do it, but you wonder how well it translates to others. And so I'm hoping everybody was able to work on the workshop themselves.
All right, I'll just say something for the quietness here. So I worked through it, but I don't see myself using it anytime soon.
Okay.
Because with federal government, we have so much restrictions that I doubt I can just send data up there. But I want to keep up with what's going on. So I won't be asking a lot of questions. So I'm going to be a very dormant participant in here. Yeah, hey, Magnus. So I had trouble uploading data to Pride to the point that I had to take it home and do it on my own computer. So this is very, very far-reaching for me. Like my work computer won't even allow me to submit to Pride. Yeah.
Okay. Yeah. So, well, at least for the workshop, you didn't need to submit anything to Pride. But yeah, there's that good thing. But yeah, I could see that, especially if like institutions and stuff limits the bandwidth and the direction and places that it can connect to, that this would be an issue. It could potentially bleed over into the cloud as well as whatever rules wherever you work, that they usually have some sort of cloud restrictions, whether it's data protection or simply preventing sample de-identification, whatever. There's usually rules, and those are hurdles that people do have to work through.
Yeah, so I don't know what you feel about the security on cloud. So I keep looking at cloud. I don't know if you read Harry Potter. So I keep thinking of cloud data storage as that secret room in Harry Potter, where if you get in there, you have access to everything, but you have to get in there.
Yeah.
The room of requirement, I think.
Yes, the room of requirement. Yeah. Yeah. So it's, I mean, it's not a bad analogy, but it is a little more complicated than that. It used to be that a lot of the cloud services, and this, I think Amazon was guilty of this as well, would just provide storage space for people, and it would just by default leave it wide open on the internet. And these days there is security protection in there, so that the only person, when you create a bucket on the cloud, the only person who has access to that bucket is the account holder. And so that's the current status. But you do sometimes want to share that bucket, and you can, because it's really confusing, and there's a lot of different ways to set permissions, that you can by mistake leave the bucket open to a lot more people than those you intend to use. And so yes, you can actually accidentally leave your protected files out in the open. It could happen.
Yeah. Hey, Pratik.
Yeah, where I used
everybody.
Yeah, where I used to work, because it was a medical school and we had so much HIPAA restrictions, we could not put anything in the cloud, even if anything we were doing was not under HIPAA, because everything was.
Yes. Yeah.
We had no more patient information whatsoever, but they would not let us do anything in the cloud. Absolutely not.
Yeah, I've worked with places like that as well, where even if there was a way to figure it out, they just don't want to mess with it. And I understand that.
Yeah, I was about to say the hospitals will have pretty much the same issue as I do.
Yeah, so I mean, what's new in the TPP these days? Actually, I know I was trying to showcase the cloud features, but we've developed an enterprise edition, which means that if you have a cluster somewhere locally, that you could install the TPP and have access to that cluster as if it was the cloud. But I mean, the software would operate the same, but it would all be local, so that you wouldn't have these restrictions about data traversal in the cloud. or anything like that. So in theory, you could run through the same tutorial on an enterprise edition of the Trans-Proteomic Pipeline. How about you, Pratik? Have you had a chance to go through any of the workshops on your own?
No, I could not. I was just recovering from COVID, so I'm just
Yeah.
back now. So, but I went through some of the video and it looked really good. I was just wondering how many people actually have tried it and had questions for you. I mean, I came a little late today, so do you have any statistics on how many people access the resource, or apart from the?
Yeah, not me. Ken might know what the viewership is on the
I will
video.
check that while we're talking. Hold on just a second.
All right.
Go ahead.
Good.
But you can't actually see who uses the Amazon cloud, right? So it's not like the Galaxy
No.
cloud where the Galaxy administrators can actually see how many people are actually logging in and running the workflow.
Yeah, no, about the only thing I could do is if I had created an account and I was going to pay for everyone using the workshop myself, and they could all create, I'd give them all a user account under my umbrella account. That's the only way I could see the traffic. But if everybody else created their own private account, then yeah, that's all of that information is personal to them. The world doesn't get to see it. Amazon gets to see it. Amazon will know exactly what everyone did on the cloud.
Yeah, we see that there have been 54 views of the recording, and one very positive comment. So that was helpful.
That's good.
So Ken, do you think we should kind of keep promoting this? Because obviously, this is, I mean, the Slack channel is open, but most importantly, people can still access it, and we can promote this. I was just wondering whether we should just directly tweet about the YouTube link. And I don't know, the Slack channel is of course open, but I haven't seen any questions there. So I'm just wondering what changes do we need to make for the Galaxy and for the next flow sessions, but also for the TPP session, because obviously we want more people to access it and know about it. And I know that TPP also holds workshops in parts of the world, right? I mean,
yeah,
I know there were,
we haven't done it in a while.
It's
for
2.5 years.
For obvious reasons, but yeah, we're overdue for doing this again. I mean, we usually hit 3 or 4 locations per year and provide education.
I know you had done one in India as well.
Mm-hmm.
And
I've done several in India. I know of 3 that were done there, and I was part of 2 of them. Yeah.
Oh, great. Yeah. So Mukul, who's also at the ISB, Mukul Mida, he also takes part and I think teaches the DI part of it, the Disco software suite part of it, and I'm sure other things as well that he's developing. So it's interesting. Yeah. Any other comments?
I'd like to say thanks to Ben for his wonderful introduction video.
I don't know how great it was, but I hope it served some purpose.
So Ben, I have a question for you because you're a federal government. How do you use cloud computing for your data? Because I can't. I had to take my data home for submission.
No, I mean, everyone's different, right? But we've, NIST, which it's funny, NIST actually writes the security guidelines for the rest of the government, but every agency can interpret it differently. But we are quite savvy. So, I mean, not to talk about like what, like using TPP, but like last summer for our summer students, we gave them all these Amazon EC2 instances. Right. And they were like already, they were like these images that fit all the things that NIST wanted with certain provisions and hours. And so that's like what they did instead of worrying about all these computers. So that's not quite the same thing, but that's, so we do that. We have AWS resources and local resources. I always talk about with Pratik, the thing that I personally use a lot or have used is Jetstream and Exceed, which is not Exceed. It's called, starts with an
Access.
A. Access.
Access. Yeah.
And that's again, that's through NSF. But no, we're allowed you got to watch with the data, right? You still have those data issues, right? They can't be certain security threats. That was a long answer. But yes, we do use it at NIST, and it is even suggested and seems to be growing.
Okay. Send your recommendation to NIH so we can use it.
I bet you do.
I don't have to take that home for submissions. I hate that.
No, I mean, you do, because I mean, for instance, like all the NCBI resources just moved to the cloud in the last couple of years. So like it's within the government. It just might be your local agency's interpretation.
Okay.
The thing with the summer students the other year was what kind of blew my mind, because you always think they're not going to do like forward thinking, and then they did it. And I think that's the dream.
Yeah. Any other questions, comments? Things people found easy in the workshop, things they found difficult?
So I guess I have one question. So I think you had at some point you had a timer for 8 hours, and then it would disconnect and then close.
Yes.
Yeah. So was there a reason for this 8 hours, or would it be a way to kind of trigger it immediately when you're done? If you know when you will be done, what your last step would be?
Yeah. Yeah, that all has to do with pipelining and everything like that. And I think it could be smarter than that, where we could have a final step and then it just kills the EC2 instance. But actually, I think the original reason, Joe Slagle was our developer who wrote most of those connectivity scripts, and he has since moved on to another job. But at the time, this is many years ago, that the EC2 instances weren't that stable, and we were usually using them on spot pricing. And spot pricing means that while it's sitting idle in the cloud, you can get it for cheaper, but you have to relinquish it if somebody else wants it. And so we were doing that, and that whole process of spot pricing means that at some point in the middle of the analysis, the computer would get pulled. And so that would create a gap. And so if we were just waiting for the end of the process, we get to the end, but Joe needed to write scripts that went back to see how many jobs just didn't finish, and then to restart them, and suddenly we're out of sequence. And he wrote all this code to do all of that. And so that's why the kill switch, as it was, is set on a timer past idleness, because you never know if after all your jobs are done that it needs to go back and revisit and rerun something that got killed. So that was the reason. And then the other reason is because before he actually put the timer on there, he completely forgot about it, and I came back a week later and was still getting charged. So that's why we actually had to put a fail-safe in there. Yeah, these days, I do think that the cloud's a lot, that the resources are a lot more stable these days. They don't get pulled away from you, because there's just more in general out there, and the computers are more powerful, and the management's better.
Any other comments or questions?
All right, so I guess I have a question for the few people who are here, if they're willing to share, or even just, do the little hand raise icon or whatever. How many people have actually had an AWS account prior to this this workshop, or is this the first time they used AWS? All right, so Magnus is the only one, and Ben, of course, yeah, you mentioned that earlier. Yeah. Okay. So I think that's good. Critique, good. Yeah. Because it's. I mean, I think this was one of the goals. But when I started the workshop, I figured, oh, I'd just make it all about the Trans-Proteomic Pipeline and everything like that. And then, it had been a while since I'd done it, and it looks different now. But I went and I decided to recreate an Amazon AWS account. For the first time in years. And when I did it now, after all these years have gone by since the last time, it looked different. It looked different enough that I just decided I had to walk people through this. So the workshop, the format changed a little bit, and it became like I think a quarter of it, 15 minutes of it became just navigating AWS's new user interface and doing it over the browser. It gets a lot weirder if you want to do it all from the console, but I didn't want to make this an expert class. This is meant to be accessible to as many people as possible. And so I'm hoping, at least, even if you didn't set up an AWS account, that you can go back to this tutorial and find it useful. And in the future, when you do need the cloud or have permission to use the cloud, that you'll be able to set it up in minutes, and pretty much the same amount of time as the tutorial itself, 15 minutes, and you'll be in the cloud.
Yeah, I was thinking it's going to be helpful for people if you have this video somewhere accessible, and also kind of have the setting of Amazon account in your title, just in case someone comes in later and say like, okay, I don't even know where I'm starting. And then also, for someone like me that basically kind of tuned half out, when I realized it's all really cloud, if you can kind of give a little leeway into what if you have a local server instead of a cloud, how are you going to use it? Because especially for the future ones, like I didn't realize TPP you can do it locally. But yeah, so that probably will be helpful.
Yeah, that's a great suggestion, and you're right. We do need more video tutorials of just using the TPP locally. Yeah, that's certainly good advice. I think we've gotten too comfortable in the past of being able to travel places and do demonstrations live. That we just got. This is the new norm now, right? We're on Zoom. Everything's recorded and put on the internet, which is technically in the cloud. So one way or another, it's TPP in the cloud.
Yes, if I can have a question also. So I know in the TPP and all these files, they have references to other files. So then with the path there, are there any special considerations or things to bear in mind when you do an analysis that you should really keep all the files together until the very end of the analysis? Or are there anything special there for when you do it on the cloud, part of it on the cloud and part of it locally?
Yeah, so that's actually a really good point. How much do I want to go into that? So what happens with all the data files that are generated, and all the results files generated by the TPP, all store the paths to the files, so that it's assumed that if they're in some semi-permanent location, that it doesn't matter where you open up one of your results files from, it'll point right back to your data. And this is important if you want to visualize your data. There's several tools that pull out spectra, annotate them, that sort of thing. And so it's good to keep your projects organized in such a way that makes sense to you, so that when you come back to them 6 months later, they still make sense to you. So don't just put everything in one data folder. Create subfolders for each project to keep everything organized. That being said, this is where I can really get into a lot of explaining, but it's probably best I don't say too much to confuse anyone. If you were to say move those projects to a new location, things like that, there is a tool called Update Paths that then updates the paths of all those files and points them into the new location, so that having moved them and broken all of those connections, you can reconnect them and you can still open up your data and access it. It's when it's on the cloud, it's a little bit difficult because connecting to the cloud needs those permissions if you want to directly access your data from the cloud. But when you move it around down the cloud, which is inevitable, you can then make all of those connections again and continue using your results. Yeah, any other questions maybe about just the Trans-Proteomic Pipeline in general? I stuck to a pretty general tutorial, something that I think would be accessible to most people. It was just a search validation step and then quick quantitation. But there are lots of other tools in the TPP. I think at last count, we're over 60 different tools sitting in there. So if people want to know more about it, what some of the capabilities are, I'm happy to explain them.
So Michael, I have yeah, go on after you.
Okay. Yeah, I mean, kind of a naive question that I should just know. But so yeah, so like, are the other like Kojak or are things like that also in this image?
Yes, they're also there. Yeah, for those that don't know, because everything is really shotgun centric in the Trans-Proteomic Pipeline, I think that's one commonality that's there. It's that shotgun centric. That anybody who has, say, a database search algorithm or a spectral library search algorithm, we can pop that into the Trans-Proteomic Pipeline. And even though I showcase Comet, because I think that's a great, simple, but still quite feature-rich database search algorithm, that there's others that are pre-packaged. And so I think we've got MSGF Plus in there. We think we've got OMSA in there. And then Kojak, which is specialized for cross-linking. So you can even do cross-linking analysis in the TPP. And then even if you use something commercial like Mascot, you can take your Mascot results and import it. We have actual pipelines that walk you through the importing process from another vendor's search algorithm to put it into the TPP. So yeah, we can definitely do all of that. Some of the other features that I didn't go over, I did a quick label-free quantitation, but there is actual label like TMT, iTrack. We do labeled analysis as well for quantitation. We support all of that. There are some precursor analysis tools that can pull out precursors. You can analyze those, even quantify based on precursor peak abundances. There's, I only briefly went over the protein inference tools, but there's a lot of additional tools that allow you to then navigate your results, like say, check out protein coverage, check out redundancies across different proteins, ways to evaluate your results and reliability beyond just having protein lists and peptide lists in the end. So we have all of those tools. We have actually, I think, yeah, I mentioned a couple of quantitation algorithms. There are other ones that we have as well. Like we use a quantic algorithm to quantify fragment ion peaks as well. That's all possible in there. And then of course there's tons of visualization tools, and we have tools that I think I mentioned just briefly. We have validation tools that validate your results. We also have tools to validate the validation tools. And I think that's important because, you know, a validation tool that tells you exactly what you want but is wrong is not a good validation tool. So it's good to always, you know, hold those up to the light every now and then and make sure that they're doing what they're supposed to be doing.
So, Michael, I had a question.
Yes.
In terms of, you know, TPP has its tools that are developed by ISB, but, you know, you also mentioned OMSA and MSGF Plus, which obviously have come from other institutes. So
Yep.
how do you decide? Do you package other tools that come from other institutes? And what is the decision behind, how do you decide which ones make it to TPP suite of tools?
Yeah, so ultimately, I think we wouldn't decide ourselves what makes it in. What we usually do is that the tool needs to be open source, but if it's not open source, at least packageable and an executable that we can put into our installer. And that means that it needs to be both Windows and you know, Linux compatible and hopefully Mac OS compatible. One example for that is Novor, so we can do de novo searching as well. And Novor is presented to us as an executable that we can repackage and distribute. And ultimately, that when we absolutely need something that we see appear in the literature, if it's open source, we go out and we grab it right away. But a lot of times what happens is the developer of the tool says, I'm looking for a platform to help springboard this. Would you be willing to do this? And our answer is generally yes. We think at least the way our software is designed and packaged, that it's a low bar for somebody to adapt their software to fit inside the pipeline as well. And so that's usually, if people come to us and they say, I want to contribute, we're happy to say yes. We rarely turn people down.
Right. And does the TPP team, or, you know, the researchers at ISB, do they, you know, there are newer things coming up, ion mobility and single cell proteomics, and, you know, cross-linking is one. Of course, there's imaging mass spectrometry. So as newer methods start emerging because of the changes in the instrumentation or developments in the instrumentation, is your team working on some of these aspects in terms of, you know, building new tools as well? And if so, which are the ones that you're developing, if you can, you know?
Yeah, so you're right. Yes, we're constantly developing and working on you know, new tools and things like that. Absolutely. I can say personally, one of the new tools, it's another search algorithm, but we're into open modification searching, and we support other tools that are out there like MS Fragger, and we're happy to do that as well. But we have our own tools that we're developing that we can package inside the TPP. And so one tool that was recently published called Magnum is one that I'm currently working on right now and trying to flesh out the pipeline and the feature set in that. So open modifications are going to be, you know, another capability. If you've I guess the original reason why I got into this is that I was working with somebody who was you know, using drugs to modify proteins and wanted to see where those adducts would appear on the surface of the protein. And so in a cassette model where you don't necessarily know what the end product, what the end small molecule is that's bound to your protein, you need to do an open search. And so this is a tool that came out of that helped them, you know, very quickly identify how their proteins were being modified with something that isn't necessarily in Unimod or another database that has this information readily available.
Interesting. And then for these modifications, do you have validation tools to kind of you know, detect the site of modification, but also to find out the probability and things like that?
Oh yeah. So David Steinberg, he's got a tool called PTM Profit, which is wonderful. It goes through and it first checks your localizations. Because search algorithms usually put the modification somewhere on the peptides. So it first checks that, and it'll relocate them if necessary, but then it goes through and it presents to you the evidence why it's relocated them and gives you a probability. And sometimes that probability is like 50%, which means if you're between two sites, it could be a toss up between the two. There's no evidence that's different between the two sites. And so therefore it's just an unlocalized modification. But other times it can tell you with some confidence that it's like 97% sure that it's at one particular site. We use it all the time for phosphorylation, very common things like that, but it's fully adaptable to any modification that you search for.
Thanks.
I guess here, I'll ask one because, so, you know, in the tutorial, right, so you had the raw files from Pride, and then, you know, you've got your access, you know, essentially once you're interacting with the image by two ways. You're transferring files there and back with some sort of FTP client, and then you are running all the tools through the web UI. That's it, right? I mean, yep. Is there, and maybe, and if you said this, I apologize, but like, let's say I just wanted to spin it up. Pratik just published a new paper, and I just want to make this remote image do all the work. So is there like a wget function or something like, can I make the EC2 download it directly?
Yes, you can. Yeah, you can. This was outside the scope of this tutorial, really, because I wanted everybody to be able to work with a graphical interface and do everything like that. But yes, all of those AWS command console tools are in the TPP cloud support. So that means you can, through a console, yes, just wget those files and pull them over. We still have to work in buckets, but you can do a direct transfer from the cloud to your bucket if you have the right knowledge for the console. Yes.
Okay.
Yeah. It brings up an interesting point. Something that I learned throughout all of this is just what goes on with files in the cloud and when you use them on different EC2 instances. So even though your files are, say, stored in a bucket in the cloud, when it comes time to analyze those files on a particular EC2 instance, it has to go into your bucket, transfer those files to your EC2 instance so they sit locally on that EC2 instance in the cloud. It's still in the cloud, but it's on that, so that they can that EC2 instance can do the analysis there. Because if it's actually doing the analysis across a mounting that is to your S3 bucket, just the transfer times and the slowdowns there on the cloud is really slow. So you move your files over to your EC2 instance. It does the analysis, it takes the results, and then it transfers them back to your bucket. And so, you know, there's actually a lot of file transferring back and forth that happens in the background, and you do get charged for this. It's not expensive, but all of this happens, which is one of the reasons why in the tutorial that I tried to work with files that were as small as possible, because it reduced the costs of doing all of these transfers that happen in the background inside the cloud, as well as it cuts down on the time that those transfers take. Because there is, even though you can spin up a lot of instances on the cloud to increase your computing power, it's actually there is that little bit of overhead that is getting that instance started and files transferred to it that slows the whole process down. And so whenever you have small jobs that require just an instance or two on EC2, it might not actually be worth it on the cloud. But if you have a really big job that has, you know, you need hundreds of instances up on the cloud, that's really where the cloud shines, I think, because then the massive amount of work it's doing is far more important than the overhead that comes with it.
Is that calculator still maintained? And because I feel like that was one of you guys were like ahead of your time, right?
I know.
Oh.
So no, it's not really
Sorry.
maintained. And I guess I could have tried, but I was running short on time to do the EC2 or not, yeah, EC2 as well as S3. Like Amazon's web services, like they have calculator tools built into them now. It's under the billing tab where you can kind of do all this. It's a little hokey. It's a bit complicated, which is why I didn't want to try to do a tutorial on that until I was, you know, more knowledgeable in it. But you can replicate some of what we do on that. But yeah, unfortunately, our calculator, which was wonderful, I think the code's a little stale. Somebody who's savvy could probably get it up and running, but I couldn't.
Yeah, and what I'm referring to is yeah, I think what that was pretty long ago, but you guys you had a series of papers where you demonstrated time and performance and cost, and then you also had this calculator, and it was all the, I mean, the TPP was just this like shining example that was way ahead of the curve. I mean, like way ahead of the curve.
Yep.
Yeah. Okay. Can I ask one more then? So let's say like a user, they want to, do you have like feature requests? Like, let's say I really wish there was a button on the thing that let me put in a PRIDE exchange number or a PRIDE number, just download it. Like, do you take requests, and how?
So I think one of the best ways to take requests or to send requests to us is probably through our SPC tools message board. I believe there's a link even on like the start page of the TPP, but it's a Google Groups message board called SPC Tools, and yeah, that's a great way to contact the developers and let them know what you're thinking, what would be helpful, most helpful to you. We do listen to ideas on there. We do. Implementation, of course, is going to be according to our development cycle, but yeah, we'd love to hear from people and get feedback. If you guys don't mind, I'm going to take a moment here. The sun has decided to come out. I haven't seen it in a while, and it's really bright. So give me just a moment. Sorry about that. That's much better.
Do you have images, kind of pre-rolled images on other providers?
That is a good question. Azure, we do have it on Azure. I'm not sure. I've never actually used Azure. It's a whole different model to their cloud. I think on Azure, it's pretty much just an image that opens up and you use the cloud computer as if it's a remote desktop. I believe. I could be wrong about that. But yeah, so we're definitely on Azure. I don't want to say we're on Google's cloud quite yet. I might be misspeaking if I commit to that, but it's probably been looked into. Oh, and the other thing I should mention, we have Docker images as well, and so you can run through Docker. So I mean, with that, I guess you can create your own cloud resources with Docker. If you can spin up something somewhere on whatever cloud and then use Docker to start an instance, then I guess you could build your own TPP on any cloud.
I think we did that again because I feel like TPP was kind of ahead of the crowd for sure. Is before a lot of things were containerized. I think it was many years back. We used it on a server because we needed some of the tools in TPP, and so
Yes.
it was just too easy, right? Like we could just boom.
Yep.
So.
Yep. Yeah, all of those. I mean, Ben, I know you're pretty advanced at this stuff, so I'm sure you have no problem doing any of that. But yeah, so those would be, I guess, if there was going to be a master class, because that's a lot of firing up consoles and working on command lines and doing that. But it's all possible. I'm glad you mentioned that. It's entirely possible to do all of that with the TPP. But yeah, you've got to be comfortable with it. Personally, I think the development of the user interfaces that Eric and Luis and before them Joe had developed, I think those things are godsends for everyone, because a user interface is just so much more accessible to people in general. I mean, don't get me wrong, even if you're comfortable with the user interface, if you take the time to learn the command lines, you can do some pretty powerful things. You really can.
I mean, like for me, like when I talk to people, or even just like myself, because I don't feel like an expert. I feel like I'm a pretty good novice. But like you get held up on just the basic, like your first step is like use WinCP or whatever it is to upload your files, and then you can get them back. And like it's so silly, but when I talk to 90% of the people, like that's their first hang up. Like, okay, I can click these buttons. I can run it once I have it, but like, how did I put things there? And then how do I get things back? Like, I'm not kidding. That's like a roadblock. It's such a big roadblock.
I understand that. So, so when I started, refamiliarizing myself with the latest AWS tool set in their console, the new console of today, I got in there and they had a file upload and download page. I thought, this is great. They have the shiny buttons and things like that. And then I realized that one, you could upload all of your files in a batch. You could, you just select them all, you hit upload, but it's really slow. It really is just one file connecting at a time. I think maybe two at most. So it didn't have those powerful tools. But then the worst part is getting your data back down. You had to click on each file as a link and then save it individually to your desktop. And that's the sort of thing that just won't work for proteomics, where we have hundreds to thousands of files that we work with at once. That's the reason why we need the cloud. We're not there to do one file analysis at a time. And it shocked me that those tools just weren't part of the console, that they didn't have that capability. So you're right. I mean, I was worried. I'm like, oh my God, how? I can't tell people to use this console to upload and download files. That's why I had to put something else into the workshop.
I'm going to confess too, it's been a while since I had opened up Amazon, and all that looked new to me. So
yeah, I know it's different.
Yeah, so maybe we are out of questions here, but so I know that you can also get there's a free tier for storage, for example, for transferring smaller amounts of data, but that there's no free tier for compute. Is that correct?
No. So this is really interesting. So while I was working with Eric Deutsch, he helped a lot on this workshop here and making sure that the instances were running right. And Eric's the one who suggested that we put up those C5 computing EC2 instances, because they have like that best mid-range I guess, compromise between power and cost, and they're fully capable for doing the analyses we need. But when you look at all the other computers in EC2, they have like these really advanced GPU-based computers that cost, you know, several dollars an hour, quite expensive. And then they have this really small free tier somewhere called, I think it's called like T1 and T2. They have two computer types in the free tier, T1 and T2. These are essentially, I don't know what they really are, but they really, the specs for them look like a Raspberry Pi. And so you're allowed to use them for free up to, I think, $750 worth of compute time a month. The problem is that they only have, I think they have like half a gig or 1 gig at most of RAM, something small like that, and they have only a small hard drive space. And so I was looking at this, and then they have the T3s, which are the next one up, which actually had enough minimum requirements to run everything in the TPP, as long as you were a conscientious computer. And so I thought, wow, this would be great. Eric, can I look into this? Can I figure out how to make this happen for free? And Eric said, go for it. And so I looked into it, and I think I can make it work. I think I can back everything down from the T3 as a minimum requirement to a T2. But it does require some fancy things. Like if you were to run your Comet search, there's a parameter in your Comet search that says batch size. And that batch size determines how many spectra it can analyze at one time. A bigger batch is better, because the more spectra you can analyze in one batch, the faster your analysis, but the more memory it takes. And I think there's a setting where I can set that really low. And so if you don't mind that it takes a lot of T2 instances, a long time to do the analysis, that we can do it inside those memory constraints, and we can make it happen for free. And it seems it's generally like a bad, I mean, we're talking like spinning up 1,000 T2 instances here to do an analysis. It seems like a bad idea, but if it's free up to $750 per month, I think you can actually do quite
I was
a bit.
thinking more in terms of developing a kind of tutorial light where you wouldn't have these hundreds of big files that you use now, like in the tutorial, but more like a simple, maybe even like just a few small files, or you can edit to take out a part of the file, just to sort of walk people through the process, and then clearly explain that, well, okay, to scale this, then you would have to change these parameters, and this is the tutorial for how to do it for real. But then you also need to pay for the compute time, but this is a free light.
Yeah, that is a good idea. Yeah, how would you make that happen? So Pratik, I think you chose this data set, if I remember correctly, and it was chosen, I guess, as a compromise between, you know, large but not too large, and at the same time not too small that it makes the cloud look impractical. That's the other, if any job is too small, you don't even put it on the cloud. But yeah, there's a way I think that we can do it on a few test samples. If you just want to try the cloud out, for a trivial amount of money, you can do it. It's a good idea. That being said, did anybody look at the costs of doing the tutorial, the workshop? If you got on the cloud and you did the computing, did you actually see how much you spent? I haven't looked. For me, it's a bit different, because what I had to do in order to make the video is it's like a cooking show. I cooked several turkeys, and the one you see come out of the oven is you know, the one that was actually, but I had to refilm different segments and cut and paste and do retakes, that sort of thing. And so, you know, my costs aren't probably as accurate, but I think most people could have gotten through this entire data set for just a couple of dollars. That it really was not that expensive to spin up these instances and analyze them.
yeah, so obviously it's extremely affordable. I agree with that. But maybe for some people, if they are a bit uncertain, maybe if they see that it's really a free tier, so there's no risk involved at all, that they would accidentally do something. I don't know. I mean,
no. That what do they call that? The freemium software model that everybody loves so much. Oh, you can play this game now, but you have to buy the in-game currency in order to continue. I could actually see models where I mean, it's the way we understand computing these days, right? It's certainly everybody can try for free and then decide whether it's right for them. And as Ben suggested earlier, if we had that cost computing tool up and running, or perhaps right there on the front page, where people can just type in the analysis they want to do and get an estimate for the work, that I think that would do a lot to really convince people of the cost benefit on the cloud. Yeah, I guess I really didn't discuss this at all, but for those who work at a place, if you're in contact with whoever runs the IT and runs, say, cluster resources and computing resources, we all know, like, desktop computers, $2,000, let's say, for a desktop computer, for you to run a local instance of the TPP as part of the costs of infrastructure. But if you were to maintain your own cluster computing for large jobs, clusters cost a lab, hundreds of thousands of dollars over their lifetime. And so when you take that into account, that especially if you're not going to run it all the time, if you don't know your usage, and if it's not going to be pegged at 90% or more used, that taking that money, even a fraction of that money, and using it towards the cloud can probably get you a year or two worth of data analysis easily, for a fraction of what it costs to build and maintain a cluster. And so I think cloud computing is one of those resources for people, especially if they're in a small group. It's highly cost effective. Clusters make sense for large institutes that have a lot of people sharing the cluster. Move to the enterprise edition of the TPP for that. But I can't see smaller labs and small research groups being able to effectively buy and maintain their own clusters for their computing. Cloud's definitely the resource that's right for them.
Any more questions, comments? Okay.
I really like the video tutorial. I think it was very, very clear and I think very well paced. So it was very easy to follow. So I liked it. So I hope that it's a nice resource, and that I will certainly point people to it when I think that someone should try out these resources. So it's very useful.
Yeah, we'll definitely make it a point to tweet the link to the YouTube video. I mean, it's really well done, and we want to be sure that people are aware of. I mean, people are aware of TPP, but also the cloud resources that they can use to use the TPP resources. So, thanks a lot, Michael, for making this. And this is kind of, as everybody knows, this is the first of the other, a 3-part series of a cloud computing workshop that we have. The next one is going to be in first week of October on Galaxy, and then in November we'll have one on Nextflow. So are there any more questions? We have 5 more minutes, but if there are not any more questions, I'd like to thank Michael for being here and for making this video, but also making us aware of the TPP resources. And I'm sure there'll be more people who will have questions as they start using this resource. So thank you very much, Michael.
Oh, thank you, especially for this opportunity and for the discussion today, and for everybody who showed up early for me. I don't know whether it's early or late for you, but thank you all for being here.
All right.
Thanks, everyone. Have a great day. Appreciate it.
Bye bye.
All right.
Bye.
Thanks,
Bye.
Mike.
Have a good day. Bye.